In this video, I build on top of the pumping experiment we did last time. So we started from the homogeneous groundwater distribution with just that right gradient of 1 meter from left to right over our 2000 meters long domain. And we started pumping at this point and continued pumping for 10 days. So you already know you can add a color bar to it, or you can add some kind of profile across it. So we just select it here. Just draw the transact across the pumping station, and we will get the pumping curve as we expected. So the variation is groundwater over our pumping station. However, you might want to have these kind of temporal changes at some observation wells, so that you know what you would expect at some points, like at real observation stations. This is not as straightforward in GRASS GIS as it is in other software, because GRASS GIS was not originally made for groundwater modeling, but it can be done, and I will just show you how. First of all, we need to get a new vector map. I will just call it observation points pretty much. We'll generate a table for the attributes, and the first one would just be the category, so the numbers I'm counting forth. So we will go with that one. That's okay. Of course, there are no points in there just yet. I click on this little yellow pencil to enable the interaction mode with this for this vector layer. And now we can place our points where we would like to have it. I'll put one very close to the well. And he will just ask me, that's okay. Oh, okay, that wasn't exactly where I wanted to have, but it doesn't matter for the demonstration. I will have another one here. I will take one a bit further away over here. And you will see it would just count the ADs back and forth. So I'm happy with 3 observation points, but you can imagine you can do as many as you like. We can take a look at the attribute table, and we just have this category. However, to store the temporal changes at all those points, we need to add more columns, and I would just call it day 0. Of course, the type is not an integer, but we have it as a floating point value, so we would call it a double here, and have the name of the column. And I click on add. So that is done, and now I do this for all the days I want to have. I mean, actually you don't need like every day, but let's go for 1 day 2, day 5, and day 10. But you could do this for as many days as you like, right? Or as you have data for, of course. So for me, that will be it. I can click on close here, and we now look at the table. Right, we will still see our 3 points here, and we'll see the new columns we generated, but of course those are empty. We want to fill those ones. We don't need the editing mode for it, so I'm clicking here. I want to save the changes, and now I want to fill those columns in my map with the new information, or with the information from those raster maps. So I can go here for the vector, of course. Now I have to find it again. I think it was here, yes, to update attributes. And we want to have updating these attributes based on raster maps. So we click on this one. You also see again, of course, you can edit this by the command line. it automatically chose the vector map we have just generated. And of course for DAO I will start with the pressure head of 0, and right, I can here put in the name of the column which you want to be updated, which would be the day 0 column, and I just click on run. Right, and now I have to do this by hand, so that's why I said it's a bit cumbersome, but you can do it either by the command line, or you could use the while function in Python, which I also introduced to last time. No, damn it, okay, not day 3. So going for pressure hat 1. To select day 1. So you could also use this while loop in the small Python editor, for example, to get those points. So 1 and 2. So that would then be day 2. What else do I have here? Think day 5 I have left. So I'll go for pressure head 5, run it, and finally pressure head 10. And this should be it. So if I now take a look at the attribute table of this vector layer, well, we see that here the groundwater level values was 29 and so on has been added. So we can close that, and now there is a nice function. You can export this attribute table. So I can click here. I prefer comma separated value, and you can just save it anywhere you like it. Hit the run button, and you would just get a text file which incorporates the attribute table you just have seen. And in the next video I will show you how you can use this text file to analyze in Excel, for example, or any other table calculation software, to then get or plot or analyze, calculate, whatever you like, based on those values. Thank you very much.